This is a continuation of section 7.1, and it's all about types of decimals, mostly repeating decimals. So let's get started. There's three kinds of decimals. Two of them are terminating. The decimal stops, like 7.1. I stopped saying any digits, so that decimal stopped, 7.1. Then there's a repeating decimal, like 7.111111, and it repeats forever, so you put a line over it to show that it repeats forever. You can even say 7.1 with a line over the 1, because the 1 repeats forever. You couldn't keep writing it. You have to either round it off or put that line up there. If you don't put the line up there, you have to say it's approximately 7.1, because you're not totally accurate. You haven't written all the ones after it. So there's two kinds of decimals: the repeating decimal and the terminating decimal. Both of those are rational numbers. And then there's a third kind of decimal, because maybe it doesn't repeat and it doesn't terminate, and that's called an irrational number. Terminating or repeating decimals, those are rational numbers. And if your decimal does not repeat, does not terminate and stop, it's called an irrational number. Pi is an example of that. Pi is 3.1415926, on and on and on and on and on, and there's no pattern. And it doesn't repeat. And it doesn't stop. So it's a decimal, but it has no pattern. It doesn't repeat. It doesn't stop. So that's considered an irrational number. That's the three kinds of decimals. Rational is either terminating or repeating, but irrational doesn't terminate and doesn't repeat. Let's try writing a decimal as a fraction or a fraction as a decimal. You can go back and forth. Let's try writing 14 hundredths. That's a fraction as a decimal. Well, let's say it again, 14 hundredths. We need 14 to be in the hundredths column. There, it's a decimal. Let's write 7/2, that's a fraction, as a decimal. All you have to do is divide. That's what this sign means. 7 divided by 2 is 3.5, or 3.5. So that's the decimal representation. Fraction, decimal. Fraction, decimal. So you can either grab your calculator and divide numerator divided by denominator, or you can notice what the denominator is. If it's a power of 10, then you can know where the decimal goes. Now that's if you have a terminating decimal. What if you have a repeating decimal, 5.33333 forever? That's what the ... means. Well, you could memorize that 0.3 repeating means a third. Try it on your calculator. 1 divided by 3 is 0.3 repeating. So this is actually 5 1/3. The period is 1. One digit repeats over and over. The same one digit repeats over and over. This is also a period of 1. One digit repeats over and over again, the 6. And you could memorize that 0.666666 is twice as big as 0.33333. So it's 2/3. So this number is 10 2/3. And that's the fraction representation of this repeating decimal. Well, you don't want to memorize all the different types of repeating decimals, so let's learn how to write 0.6 repeating as a fraction. And I've done the work here. So we're going to say x is our repeating decimal, and then we're going to multiply both sides by 10 just for kicks. 10 times x And 10 times 0.6 means move the decimal once, 6.666 repeating. And then I'm going to put underneath it the beginning part, x equals 0.6 repeating. Then I'm going to subtract the left side. That will give me 10x minus 1x is 9x. And then I'll subtract the other side. 6.6 repeating minus 0.6 repeating. Those chunks cancel out, so it's just 6. Then you can divide both sides by 9, and you'll get 6/9 as your fraction. Divide the top and the bottom by 3, and you'll notice that 2/3 is the same as 0.6 repeating. Let's do a more difficult question. Let's rewrite 0.123, 123, 123, 123 as a fraction. The period is 3 because 3 of the digits after the decimal repeat themselves. So we're going to multiply our decimal by 3 zeros. 1,000 times x and 1,000 times 0.123, which means move the decimal 3 times. 3 zeros means move the decimal 3 times. So it equals 123.123, and that keeps repeating. All I did was move the decimal to the right, and it kept repeating. Underneath that, I'm going to put this x equals 0.123 repeating and subtract them. The cool thing is when you subtract the 0.123 repeating forever from the 0.123 repeating forever, they cancel out. So we have 1,000 x's minus 1x, that's 999 x's. And then these canceled out, so it's just 123. And then you can divide both sides by 999. There's your fraction. You can reduce it if you want. I know the top will divide by 3 because 1 plus 2 plus 3 is 6. I know the bottom will divide by 3 because 9 plus 9 plus 9 is 27, and that's divisible by 3. So the top and the bottom are divided by 3, and there's your reduced fraction. This fraction is the same as 0.123, 123, 123, 123, and so on. That's all the work I just did on the last page. This one's a little tricky. See how it's different than the first one I asked you to do? The 1, 2, 3 isn't repeating, only the 2, 3 is repeating. It's a 2-period cycle. If I move the decimal here, that wouldn't be enough to line them up and subtract. I need to move the decimal here, here, here to line them up. So I need to multiply, let me think, by 1,000 maybe to get them to line up. I want to have only the 2, 3 repeats. So I want to have a 1, a 2, a 3, and then my 2 3s to match. So I'd like my decimal right there. I moved the decimal twice because it was a period 2. I moved the decimal right here, 1, 2, period. And then when the decimals lined up and these lined up, then my repeating parts lined up. So I moved my decimal 2 spaces, that's times 100. Both sides times 100. 0.123 times 100 means move the decimal to there. 12.3 and then 232323. That's confusing, but you can stop and pause and watch that again. So I'm going to subtract the left side. That's 100x minus 1x. I'm going to subtract the right side. That's 12.323 minus 0.123. The 2 3's and the 2 3's cross out, so I have 12.2 remaining. I still don't want a decimal in my answer, but at least I don't have any repeating parts in my answer. So I want to move the decimal one more time. So over here I'll move the decimal one more time and make it 990x and 122 on the right. Then I just divide both sides by 990, the number in front of the x, because I want x by itself. So x equals 122 over 990. That can be divided by 2 for sure. That gives me 61 over 4, trying to do this in my head, 9, 0, 8, 9. That doesn't sound right. I think there's a 5 here. Let me do it on the calculator. 990 divided by 2. Yep, 495 on top of 61. And if we've reduced it enough, that's our answer. 61 over 490. 5.